let's actually connect some of that. Let's see, I'm gonna rewrite that. Let's get a clean board. So I have negative kx is equal mass times acceleration. So let's just assume a sine curve. So I have negative k times a sine omega t equals m times acceleration, which is negative a omega squared sine omega t. Let's cancel stuff out. I got sine omega t and sine omega t. Wrong one. That cancels out. I've got a and a. That cancels out. I got a negative and a negative. Those go away. And what I'm left with is this spring constant is equal to mass times omega squared. So, therefore, omega is equal to, well, we'll put in the intermediate step, omega squared is equal to k over m. Omega, the angular frequency, is the square root of k over m. Let's take it one step further. I know that omega is the number of radians per second. Frequency is the number of oscillations per second. So in one oscillation, or just think about in one cycle in the circle, how many radians are there?
1, 2,
2 pi. So if I take my frequency, the number of oscillations per second, and I multiply times 2 pi, I get the number of radians per second, which is angular frequency. So this is frequency, the same frequency we talked about before. And this is angular frequency, which maps very closely to, I got a circle that's cruising around at a speed of omega. So therefore, my frequency is omega divided by 2 pi. So frequency is equal to 1 over 2 pi times the square root of k over m. So once we establish that we have something obeyed in Hooke's law, not only do we have a formula to a model for the position, velocity, and acceleration, we know can figure out the angular frequency, the frequency, and the period. So given that's the frequency there, what is the period of this spring? Which comes down to what's the relationship between period and frequency. Therefore, what is the period? Formula.
2 pi over omega.
That'll be in terms of k and m.
Okay. 2 pi square root m over k.
Now, this makes sense if you get stuck and you're thinking it's k over m or m over k. Well, think about it. I got a slinky here with some spring constant, some effective mass. I add a mass to it. I pull it down and I let go. If I increase the mass that I have hung on the end here, so I put a 1 kilogram mass, assuming this doesn't deform, I put a 1 kilogram mass on here instead of just a 10 gram mass. If I put a 1 kilogram mass on it, I got more mass, more inertia, harder to move, easier to move.
Harder to move.
So as the mass increases, the period increases because it's harder to move it. K is a spring constant, deals with how stiff the spring is. If the spring is incredibly stiff, it's going to snap back quickly. If it's incredibly loose, not so much. So as K increases, we're dealing with a much tighter spring, something that wants to snap back to equilibrium. So as K goes up, the period goes down because it's going to be moving faster. I'll throw one other thing into here, and then we'll call it a day. We're doing sine here because Jack said sine. Perfectly fine. My recommendation is, when you have simple harmonic motion, you can either use sine or cosine, whichever one. If it starts at the equilibrium position, if that's when time is equal to 0, sine is probably the best choice. If it starts at the amplitude, cosine is the best choice. If it starts at its maximum or minimum position, I would recommend cosine. So you're just starting here, the velocity, acceleration, jerk, snap, crackle, pop.
Will those be given on a quiz?
No, by the time you get to the quiz, it'll be just natural.
That's awesome sauce.
Absolutely. Actually, they might be, I'd have to look again what I've done in the past. But it should just be natural.
This would be chapter, still 16?
16, 17.
16.
Sorry. Get confused which one's which. I will say that the textbook doesn't use omega here. They use 2 pi f, and so they would write this as 2 pi f t instead of omega t. I think I have the book's formatting and then my formatting. On that note, have a lovely weekend. And I think there's a calculator still up.
You have to pass it, I know you didn't pass this stuff out, maybe last class.